Hello. Tonight, the whole of MicroLive is devoted to the microprocessor revolution in cars. Now, we'll be looking at why boxes like this one are becoming commonplace in the previously low-tech motor industry. We're starting in the highly competitive world of Formula One racing, where every hundredth of a second counts. There, the designers are increasingly turning to microelectronics to give that extra edge over their rivals. And that's why in the pit lane these days you'll find lap-held computers as well as grease guns. It's being suggested that soon, without computers, the teams won't be able to go racing at all.
This is the home of Tyrell Racing, an elite team devoted to building cars like these. Formula One has some of the best mechanical engineering around today. It's closer to the aerospace industry than the motor trade. The body shells are incredibly strong, yet remarkably light. They hide engines which are at the center of every boy racer's dreams. Even the suspension systems are forever being refined and developed. Tyrell are not in the business of mass production. In fact, they probably never make more than 5 of the same car. But to stay competitive, their cars have to be continually redesigned. Winning Formula One these days has as much to do with the design of the car as with the skill of the driver. The race can be won or lost on the drawing board, so you need the most up-to-date drawing board you can get. And if your sponsor is a computer company, it's natural to use one of their computer-aided design systems. We asked Bob Tyrell why such a system is particularly valuable in his line of business.
In a Grand Prix season, we have a Grand Prix virtually every 2 weeks. And that means that there is never any time to do things. There's never enough time to design, and there's never enough time to make things. And essentially what the CAD system allows us to do is to do things in a fraction of the time than it would normally take through traditional techniques.
Its real value is for reworking designs.
A Grand Prix car's got around 1,500 different components, and probably 70% of those we're continuously modifying during the year. And so a component that you produce, say a component in the front suspension, might be obsolete within 2 weeks of you having made it. With a CAD system, you call up the old design in the computer, have a look at it, alter some of the parameters, and you've got your new design. It just saves a phenomenal amount of time.
Once the designs are finalized, the dimensions are passed to another computer, which controls a milling machine. It's a form of computer-aided manufacture. The design system can also be used to model vital bits of the car, like the suspension system.
What mathematical modeling really is, it's creating a mathematical description of the physical characteristics of a car or a car component. So what we're really doing is we're translating physical characteristics into mathematics, and that's, as you know, mathematics is what computers know best.
The mathematical model allows the suspension structure to be varied inside the computer and the changes in performance monitored. Here, the red lines are the lower part of the suspension wishbone, the green line the upper part, and the yellow line the axle.
Through the CAD system, you can input a model of the car or the component into the computer, and then you can then impose different forces on it. You can impose aerodynamic forces on it or physical stresses onto it, so that effectively you can see how a component reacts when you put different forces onto it. Ultimately, you always have to try out new ideas on the track. But what we're trying to do is to save the enormous time that's involved in track testing. And what the CAD system is going to enable us to do is to weed out the 90% of the ideas that are bad before we actually go and test them on the track. The ultimate objective is to simulate one of our racing cars going round Silverstone so that we can know what the car is going to be like when we come up to the British Grand Prix. What you would need to do is to actually have a geographical model of the circuit, which would include every rise, every dip, every bump in the circuit. And ultimately, that is the way that Grand Prix car design is going to happen. We think that we're about 6 months ahead of the rest of the field, but I think you can safely say that any Formula One team that is not operating a comprehensive CAD/CAM system in the next 4 or 5 years just won't be in business.